Hello and howdy everybody. We're looking at question number 20 in this video. Question 20 from the 2004 Cayley competition. So if you haven't, download a copy of the contest by clicking one of the links below. You can get it, try question 20 for yourself. It's a good question. I mean, question 20 is usually pretty difficult, even though it's not in part C, which is sort of the big, scary, these are the hard questions part of the contest. Question 20, sometimes even question 19, can still give you some time to scratch your head because you just don't quite know what's going on with it. Let's hope that's not the case this time. Let's hope it's fairly smooth and straightforward question. Let's take a look. An archery target has 3 regions, each worth a different value if it is hit. 3 archers shoot 2 arrows each and record scores as follows. The first archer has 1 arrow in C, 1 in A, and he's got 15 points. Second archer has 1 in B, 1 in C, and 18 points, and then 1 in A, 1 in B for 13 points. If a 4th archer shoots 2 arrows into ring B, her score is... Okay. What to do? So, really what we need is sort of just 2 times the point amount for B. So if we can work out the point amount for B, I don't care what A and C actually are. Okay? And this might help guide what exactly we do. Okay, now I can think of a couple of approaches. What I'm going to do first is just let A be the point value for the region A. So we have some equations here. Our first archer is A plus C is 15. And then we had B plus C is 18. And A plus B is 13. And we want 2B, because she hit 2 arrows in the B section. Okay? So I'll just double check that I did get those right. B plus C is 18. Okay, yeah. Alright, so there's sort of 2 ways I can think to go about doing this. One, we can directly work out 2B from these equations. And that's fine. I'll show you how to do that in a moment. But usually when I'm confronted by something like this, and it's not always as simple as just 2 things and they're each used twice in different equations, but you will get this every once in a while. So for example, you can get like x plus y plus z is equal to something, and then x plus y plus w, and then w, or x plus z plus w, and then y plus z plus w. Each of the letters is used in every equation but one, and only once in each of those equations. You'll get these sorts of things every once in a while, and a great strategy is just to sort of add them all up. Okay, each letter is used a predictable number of times, so we'll get 2 copies of A, and 2 copies of B, and 2 copies of C, and if we add up on this side, 15 plus 18 is 33, plus 13 is 46, I think. Yeah, 46. So now I have A plus B plus C as long as I divide by 2. Divide by 2, we get 23. And that's great. Now if I wanted any individual value, say I wanted the value for B. Well, I know what A plus C is. So I just subtract, and I'm left just with B. B is going to be 8. I have a double B, I get 16. If I wanted C, I could do A plus B is 13. And subtract C is going to be the only thing left, because here's the A and the B, and they're already accounted for. The only thing left is this C here. So C is going to be 10, for example. And that's a great strategy. Now, they're just specifically asking for 2B, rather than, say, variations on this question, if it were a written contest, would be, determine what A, B, and C all are. And so we would use this strategy and get A, then get B, then get C. We can get all of them separately. Okay, so that's sort of something to keep in your back pocket. Each letter is used once per equation, except it doesn't appear in one of the equations. And when it works like this, you get n equations, add them all up. You'll have n minus 1 A's, plus n minus 1 B's, plus n minus 1 C's. And then if you divide both sides of the equation by n minus 1, you'll get A plus B plus C plus D plus E and from there you can sort of subtract. It's a great strategy. I like it. But I said there's a faster way to get 2b, and I did mean it. So let's go back and take a look. I'm just going to flip the page, give myself a little bit more room. So you can do it that way and specifically solve for b. Or we can say, well, a plus c is 15. B plus c is 18. A plus b is 13. And again, if we add them all up, we'll get 2a plus 2b plus 2c is 46. Well, here's my 2b. So if I just did 2 times a plus c, which will be 2 times 15, which is 30, and subtract that off, that'll get rid of my 2a's, my 2c's, and I'll just be left with 2b is 46 minus 30. So it's a little faster. We didn't have to actually work out what b is to then double it and get 2b. It was sitting right there in our big equation all along. But either way, we get 16 for her score. Okay, and there it is, C, 16. And we can sort of see, this does make a little bit of sense. The way the numbers are going, you can sort of tell A is going to be less than B is going to be less than C. So 2 B's should be bigger than A plus B, but less than B plus C. So we'll definitely have 14, 15, 16, or 17 as our answer. Then we get 16 in total, so that's not bad at all. Okay. Yeah, that does it for B part of the contest. We're going to start part C in the next video. So that'll be question 21. I do encourage you, if you haven't already tried part C, download, try it for yourself. Seriously, practice is the best way to do this. But either way, I'll see you guys for question 21 in the next video.